Good morning to all the participants. Dr. Siddalingesh Navalgund is Assistant Professor in the Department of Electronics and Communication Engineering in Sri Dharmasthala Manjunatheshwara College of Engineering and Technology, Dharwad, Karnataka. He has done his BE from Karnataka University, Dharwad. He has completed his MTech from VTU. His specialization in MTech was microelectronics and control systems. Most recently, he is awarded PhD from Vishweshwaraya Technology University. Congratulations, sir. His research interests are very large scale integration, digital signal processing, fuzzy logic, embedded systems. Most important research activity of Dr. Siddalingesh was design, synthesis, and implementation of optimized discrete cosine transform based signal processing system for multimedia application. He was working as a team member. This was funded by AICT New Delhi. It was in 2012 and 2014. He has handled over more than 20 training programs. His areas of interest in training program are exploring pointers in C, scientific computing using Python, introduction to signal processing using MATLAB, object-oriented programming using C++, data structures and algorithms, fuzzy logic, network analysis, refresher courses on digital circuit designs. He is member of various organizations. Some of the important organizations are Computer Society of India, IEEE from USA, Institution of Engineers, Indian Society for Technical Education. He has various honors. Most important honor was he was awarded the Best Teacher Award in SDM College of Engineering and Technology 2 times. Exemplary performance in teaching was he was awarded 2 times. He was awarded National Merit Scholarship during his engineering studies. Most importantly, he secured 18th rank in Karnataka during SSLC examination during 1994. Congratulations, sir. We welcome you from Department of Computer Science from SGR College. Welcome to the webinar, sir. Sir Navalgund, sir.
Yes. Hello, sir. I just want to have a check. Is my monitor visible to all?
Yes, sir. Yes, sir.
Okay. Very good morning, sir. Good morning to all the participants. This is SS Navalgund from Department of VNC, SDM College of Engineering Technology, Dharwad. We are here for the webinar hosted by SGR College of Science, Arts and Commerce. It's my privilege to be associated with you all, talking to you about scientific computing using Python. This is a very quick reference set that I have gone through. The main reference is by Christian Hill, the book on learning scientific programming with Python. And then for the basics of language, I have also referred to Sandeep Nagar and T.R. Padmanabhan books. Alan B. Downey talks about in-depth concepts regarding how Python can be used for the purpose of very prominent operations with respect to scientific computing. Along with this, there are also so many online resources which are referred to. This is the agenda for today. We start with the basics of Python, the data types and data structures, flow control structures, how do we plot with the help of Pylab package. Then we will also talk about NumPy, SciPy, and then followed by a summary. So basically, we're going to have a very quick introduction to Python and those constructs which will help us in terms of doing some good computations with respect to Python. So at the outset, this is how I feel when I try to describe Python. It is like the tale of a few blind men trying to touch an elephant and trying to explain how it looks like. Well, each one of them have their own perspective. If I look at the first blind person over here on your screen, when the person touches the tail of an elephant, he or she is going to describe it as if elephant looking like a snake. One more person touches its body and feels very tough and rough about it. So he describes the elephant as if elephant is like a wall, so on and so forth. I would say that Python is just like this very huge elephant. It has many, many aspects. It has many, many usages and application domains. In today's webinar, this is what we're going to do. Python can be used for web development, GUI development, scientific and numerical computing, software development, and so on. But the focus today is going to be just on scientific and numerical computing. So we'll be talking more on how different data types and structures that we are going to study will help us in doing so. Now, this is just for the beginners. Many people feel that when I say Python programming language, the picture of a snake pops up in the minds, and we simply don't know how a snake is connected to this language or why this language is named after a snake. At the bottom of your screen, you can see the creator or inventor of Python language. This is Mr. Guido van Rossum, a Dutch programmer. In his younger days, when he watched the television, he was obsessed with one comedy show during the year 1969 on the British television. The title of the comedy show was Monty Python, just like it's a name, just like what we have in terms of Mungeri Lal, so on and so forth. This is the cast and crew of the original British comedy show. On the right hand side, you can see the picture of the same cast and crew approximately 40 to 50 years thereafter. So since Mr. Guido van Rossum was obsessed with this comedy show, when he invented a new language, he thought of naming it as Python. A very quick refreshing basics of what Python is all about. Python is basically a general purpose programming language devised by Guido van Rossum way back in 1989. Yes, this is true. In fact, we keep on saying that Python is a very new, relatively fresh programming language, but it can have its roots. The roots can be traced way back to 1989. Well, officially it was released in the 1991 year, but the roots are during 1989 age. It's a high-level programming language. It is at a much higher level when compared to C language. That's what I would like to say, because of its expressive syntax. By expressive syntax, I mean the way in which different constructs can be written for the purpose of implementing given functionality are way higher up when compared to C language. It also supports a rich set of native data structures, such as lists, tuples, sets, and dictionaries. Let us try to go through the basics of each one of them. Let us consider an example. People would immediately understand this program. In this program, I just want to display three names, and hence we start with hash include header files like standard.io.h, stdlib.h, string.h. And then we also define the macros like max string length as some number and so on and so forth. Then we start with int main. We have variable declaration and then a character name of so on and so forth. And then we try to copy the string using the functions available in a string.h file. The names are Isaac Newton, Marie Curie, and Albert Einstein. So using a simple for loop, I'm going to print them on the screen, and that's it. So this program basically takes some three names and gives them back on the screen. That's the C program for us for this purpose. Well, let's try to compare this with what program in Python looks like. It just looks like this. The core logic consists of just 3 lines. The first 2 lines are the comments. So if you neglect them, we simply say names is equal to Isaac Newton, Marie Curie, and Albert Einstein. And then I set up a simple for loop. Let us not worry much about the syntax right now. So for name in names followed by print name. That's it. The output will be as shown on your screen. So there is no any headache associated with missing off a required header file or not remembering a particular function for the purpose of string manipulation, so on and so forth. It is as simple as this. This should talk about the power of Python. How does it work? Basically, please note, Python is an interpreted language. It is basically an interpreter. That means it executes one line at a time. So if I have a 10-lined program, if the first 6 lines are perfectly okay, I can still execute them. And then starting from 7th line onwards, I'll have a problem. But please note, in the case of a compiler, as all of us know, The compiler wants us to have 100% program intact or correct. So please understand that Python is basically an interpreted language. The syntax philosophy of Python is very simple. It says there should be one and preferably only one obvious way to do something. This is a matter of great ease for all of us. What are the advantages of Python? It has a very clean and simple syntax. Best thing is it is free. That means it is not any proprietary language or any proprietary software is provided to do some kind of programming along with this. It provides cross-platform support. That means I can always develop applications on machine X for machine Y. That's a very great news for all of us. It also has a large library of modules and packages in terms of having something like NumPy, SciPy, Matplotlib. This is just a couple of examples I have shown here. It is very easy to learn, relatively easy to learn because of a very, very simple syntax. It also provides support for multi-paradigm languages. That means we can do procedural programming or object-oriented programming as well. However, when I say this, I don't mean to say that Python is a panacea, Divyaushadha. No, it has its own share of disadvantages. The first one of them being speed of execution. When I say speed of execution, since Python is implemented on C language platform, this is going to be a wrapper on C language, and hence there is always a delay associated with respect to execution. It is very hard to hide or obfuscate the source code. Well, there can be a set of people who try to obfuscate or make the program look very tricky so that others don't understand it or don't decipher it. Well, this kind of thing is not possible in Python. And of course, there are a couple of compatibility issues between Python 2 and Python 3. Python 3 being the latest version of the language we have. This is a very limited set of 29 keywords with the help of which the entire show is being run. We have keywords like and, assert, break, class, continue, finally, global, if, import, so on and so forth. So people can visit the following websites for the purpose of installing Python-related softwares: continuum.io/downloads. You can also visit the sourceforge.net for free downloads with respect to NumPy, SciPy, Matplotlib, and IPython. Now, let me just try to illustrate one such software that I have installed on my machine. I hope that the participants can see the screen now. Please give me a nod if you can see the screen clearly. Is the screen visible? Okay, so this software is called the Anaconda Navigator. This is basically a set of different softwares for doing different things with respect to Python programming language. So we do have a cmd.exe prompt, the Jupyter Lab, the Jupyter Notebook, so on and so forth. So each one of them have their own set of things to do. Now let me focus on one such software called Spider. Spider. This is basically an IDE or integrated development environment, which actually gives me flexibility in terms of writing the Python programs and interpreting them and running them, debugging them, so on and so forth. So you just have to click on it, click on the Spider IDE. The version is 4.0.1 on the machine, and it's going to look like this. This is the Spider IDE for Python programming for beginners. Now, on the left-hand side of your screen, you can see the Spider editor. This is the place you are going to write all the programs. On the right-hand side, you can see here a console-like structure, which can actually provide you some help text. It can also help you with respect to the viewing of different variables that are there in your current workspace now. Then if there are any plots, they will be shown here itself, along with a list of files that are there in your current path. Now at the bottom right corner of the screen, you can see the IPython console. IPython console. In this case, I have gone for IPython 7.12.0 version. It is basically an enhanced interactive Python shell or interpreter. So this is how the command prompt is going to look like. This is the place where I can issue one command and get the output for. So if you can ask me a question like, what is the difference between this space of spider and this space of spider? Well, it's very simple. On the left hand side, I have a text editor. That means I can write a sequence of such steps and then run this program. On the right hand side, I can just execute one line at a time. So this provides for interaction between the user and the software. So this is the software I want to have for the purpose of illustrations. So moving ahead, let's try to have a very quick look at data types and data structures supported by Python. First thing is the Python shell. Three chevrons, greater than, greater than, greater than, these three symbols, they're called chevrons, indicate the command prompt. Now this is what the command prompt looks like in the basic or native version of Python softwares. But once again, as I've shown you, IPython interactive interpreter can have a different set of command prompts. There are basically three types of numbers provided in Python. They are integers, floats, and complex numbers. These are three different types supported. Let's very quickly go through the important aspects of different types of numbers supported. The first one is called integers. Now, it is very, very important to understand that there is no practical limit on their magnitude. For example, people would understand this fact. If I have a 32-bit machine, the size of an integer is going to be 32 bits, isn't it? Now, if I have a 64-bit machine, the size of integer will be 64 bits. Now, if I want to have a larger number when compared to this, it is simply not possible. Then I have to go for different indirect ways of doing it. But in the case of Python, there is no limit on the magnitude of an integer I can have. This is a very, very big difference between what we usually had earlier and Python. And we say integer arithmetic is exact. When I say integer arithmetic is exact, if I add two numbers, let's say 2 and 2, the answer is 4. Very simple. What's the meaning of the term exact? Let me just go to floating point numbers and then illustrate this concept to you. Floating point numbers are indicated with the help of a dot. This is what we all know. Let me consider an example. If I have some kind of operation like 4/3, the answer is a recurring decimal pointed number like 1.3333. It just goes on. So infinite number of digit 3 must be written here for the purpose of writing the answer for 4/3. Well, is it possible for me to represent this number exactly in a computer memory? Unfortunately, the answer is no. Because of the binary number representation, after the decimal point to the right hand side, we have the place values like 2 raised to -1, 2 raised to -2, 2 raised to -3, so on and so forth. So we will not be able to have any combination of bits with the help of which I can indicate the number 0.333333 exactly to infinitesimally long number of places. So we say that floating point number arithmetic or representation is not exact. On the contrary, let me come back to integers. Integer arithmetic is exact. That means given two integers, if I add them, subtract them, multiply them, or divide them, or take the mod of it, it is quite possible for me to represent those values using the binary bit pattern exactly in memory. Well, this is not possible in floating point numbers. And hence we say that floating point arithmetic is exact. Python floating point numbers are indicated like this: 2.0 and 1.23E4. Now this is obviously the scientific notation corresponding to the number representation. It's also possible for me to write this as a capital E for the purpose of representation of number. The third important type of numbers, they're called complex numbers. They are denoted with the J symbol, and basically the complex numbers also make use of a floating point number representation, and hence we can say that complex number arithmetic is also not exact. So if I have to indicate a number like 2.3 plus 1.2j, I'm going to indicate it like complex of 2.3, 1.2 in Python, as simple as this. So this is going to be equivalently interpreted as 2.3 plus 1.2j in Python. So these are the three different types of numbers we have. Let's consider one simple example where we look at Python shell as a calculator. Now, different set of operations are possible. The operators are addition, subtraction, multiplication, slash, double slash. Well, wait a minute. What is this? Slash and double slash. There's a big difference between both of them. Single slash means floating point division. Double slash implies integer division. Then we have the modulus operator and exponentiation operator or exponential operator. Let us try to consider a couple of examples and then understand how I can make use of the Python shell itself as a simple calculator. The first example is 2.7/2. So obviously this is a case of single slash. So I'm talking of floating point division. Obviously the answer is 1.35. And then when I say 9/2, the answer is 4.5. If I say 8//4, I'm talking of integer division. So the answer would be 2. On the contrary, if I just have single slash, the answer would be 2.0. That's very crucial. 9//2 implies 4, so zero point 0.5 is gone. 2.7//2 is 1.0. Well, wait a minute, what's happening here once again? Please note here that if one of the operands is a float number, the answer will be float. But you can observe here that the division is still integer division, right? So 2.7//2 is still 1. The answer is 1. And hence it is indicated as 1.0. Now, the mod operator is indicated here. 9 mod 2 gets me 1. 4.5 mod 3 gets me 1.3. Well, once again, you would appreciate the significance of last operation that I'm trying to show you here, because this kind of operation are not allowed in C or C++ language, because modulus operator is defined only on integers there. But here, mod operator works even on floating point numbers. So we can say that the number returned is an int only if both the operands are integers. Otherwise, if any one of them is a float, then in spite of having integer division, we can still have an integer output. So let us consider quickly the set of mathematical operations we can have. ABS stands for absolute value of a number. So in this case, I have shown abs of minus 5.2. The answer will be 5.2. Abs of minus 2 gets me 2. And abs of 3 plus 4j gets me 5. So you can see here that the types of input operands are changing. The first one corresponds to a float number. Then we have a negative integer. And third one is a complex number. So this is a classic case of polymorphism. All the people who would be familiar with object-oriented programming, they would know this. So polymorphism is having the same function name, but the function being able to act on different types of data at different times. That's polymorphism. So that means Python also supports object-oriented programming in a big way. This is a very partial list of functions available in the math module of Python language. So if you want to find the square root of a number, you're going to say math.sqrt of x, exponential value, then math.exp of x, so on and so forth. Trigonometric functions are also possible. So you would say math.sin x for calculating the value of sine of x, math.cos x for cos function, it just goes on. Not only this, inverse trigonometric functions are also possible with the help of math module. And then hyperbolic functions, inverse hyperbolic functions are also quite possible. Now, how do you make use of math functions for the purpose of getting the output? First of all, we must import the math module available. So I would say math.cos of 0. So that's going to get me the answer as 1.0. Math.square root of 16 is going to get me the answer as 4. Now, if you look at it, math.sine of math.pi. What is this pi now? Please note, the math module provides two very useful non-function attributes. First one is called pi, and then we have e. So when I want to find the value of sine of pi by 2, I can simply say sine of math.pi/2. So that gets me the answer as 1. So this is as simple as this. Let us also look at a very important concept called variable declaration. Well, In Python, we need not declare any variable at all because it's a dynamically typed language. So then the question would be, how do I understand that a given variable is integer, or is it float, or is it of type complex? Well, it's very simple and straightforward. It is said that if you look at a bird, if you look at a bird, if the bird walks like a duck, quacks like a duck, and swims like a duck, then the bird must be a duck. This is very funny. So if there is a bird which quacks like a duck, walks like a duck, and swims like a duck, then the bird must be a duck. So as to say in Python language, now if you make use of a variable, for example 3, as in this case, now it doesn't have any decimal point associated with it, it doesn't have any j term along with it, then it appears as if it resembles an integer. Then I say this number must be an integer. If I look at minus 0.5, the last point over here on your screen, it has a decimal point associated here, or a floating point associated here. So that means this number must be a float number. So the necessary object type is inferred from its definition, and that's a very big difference when compared to other previous programming languages and Python. So there is no any need to declare the variables. Let us look at the first ever Python code that we're going to have here. All of us are very much familiar with the Heron's formula for calculating the area of a triangle with the given sides A, B, C. So the formula is as simple as this. It is nothing but the square root of product of some terms here, where S is defined as A plus B plus C slash 2. So I have just taken some numbers here for A, B, C, and I'm trying to find the area of this triangle. So let me just try to see how this can be done on your software. So I'm just going to go to the Spider IDE. Now I have copied this program over here. So please note here that the first line is going to be import math, because otherwise I cannot find the square root of a number, because I must say math.sqrt of S into S minus A, it just goes on. So now it's time for us to run it. So you are going to look at the output on the right hand side of your corner of the screen. So please observe. It just runs the program, and the output is obtained. Now, well, what about the output value? It's quite possible for you to go to Variable Explorer tab here, and then indicate the different values available in your current workspace now. So the value of area as calculated because of these numbers is 4.63, so on and so forth. Well, it's also possible for you to type in the variable name in the command prompt or at the IPython command prompt and then cross verify it. So you can see here that in followed by some number corresponds to the input that I'm trying to give it to IPython shell. Out indicates the output that is provided by the IPython interactive shell to me or the user. Once this operation is done, then the interactive Python shell is ready for the next command or next input as shown here. So it's very simple, as simple as this. Now, some people can have apprehensions like, what is the use of this program? Because if I run this 1000 times, the output is going to remain the same. It's quite possible for you to make it more interactive. For example, if you observe on line 8, this is a statically initialized number. We know this. But if you do not want any such number, then you can still make use of a command called input. And you can just try to have a string. For example, enter the, let's say, value of side A. That's what possible. So let's try to understand how this works. I'm just going to click on the run button and then see what kind of output we get. I'm just sorry for the spelling mistake there. Okay, enter the value of A. I'm just going to say 4.503. I hit enter, and then there's a type error. What's the problem? Well, we need to understand this point very carefully. Now, if you actually look at how this particular input method works, it works in a very, very funny way. That is, the output of this particular method is a string. I repeat, the output of this particular method called input is a string. So I expect some float number. For example, I just entered 4.503 here at the command prompt, but 4.503 is not taken as a float value. That is very crucial. To illustrate this concept, I'm just going to type in at the command prompt. I'm just going to type in at the command prompt, and then let us see how it actually behaves. Let's say x is equal to input of enter a number. For example, this is my string. I just hit enter. The string is displayed, and then let's say I try to hit 8 and press enter. So let me just check what kind of output we have or value stored in x we have. So look at this. It says 8, but please observe these quotes, single quotes. Now this means that this is not an integer as expected, but this is a string. This is a string. So you cannot actually try to have a string getting added to integer like b and one more integer or float number like c, and then you try to divide by 2. Not possible. So what we must do is we must just go for a small change here. We must make sure that you try to change the string into, let us say, float. Okay, now let me just try to hit enter. Now the input I'm going to give is, let's say, 4.5, for example. I hit enter. Now the value of x, if I try to cross verify, now it is 4.5. Now this is a proper float number. This is a proper float number. So that modification I must be doing here, and hence we have a float of enter the value of a, and then I just try to finish it. And then the same thing I'm going to copy here and then paste here for the purpose of making this program more interactive. I'm just going to have b here, and the same thing is true for the third statement as well. Now let's just try to run this program and see how it behaves. Okay, now on the right hand side of your screen, the bottom part, here we have the values to be entered. For example, I will give this as 4.503, and then the second number as 2.377, like the original numbers we had, and 3.902. And when I hit enter, the area is obtained. So what is the value of area of the triangle? That's as expected here. Now this program works. So this is a way in which you can make your programs much more interactive. Okay. Then moving further, there are a different set of operators supported by Python. So we have comparison operators, and then logic operators like and, or, not. Now this is just like what we have in the case of other languages as well. There is a special mention of strings I must have here, because strings always play a very important role in Python. So it is as simple as saying something like greeting equal to hello sir. Greeting is equal to hello sir. Let me just try to tell you the significance of this. In C or C++ language, you cannot simply assign it like this, right? So you need to make use of the string copy command, or strcpy, for the purpose of assigning a string literal to a string variable. But in this case, it is simply not required. So a string object in Python is supported of type str, and you can perform different set of operations. Once again, let's go back very quickly to the Spider software, and then let's understand how it basically works. So for example, if I have a string like a is equal to hello. Now if I just want to check the kind of value stored in a, it says hello, single quotes. That means that it is a string variable. Then we have b is equal to, let's say, world, the classic string we have known from the days of C language. So if I do something like a plus b, then the output will be just hello world. Now if I just have a small space here in terms of having the value of string a, and if I try to perform different set of operations, for example, I can always assign to C is equal to a plus b, and then the value of C would be like hello world. Or it's also possible for me to just place A and B side by side with appropriate syntax. I just sorry, not A and B, but the values of them. For example, hello and world. You just hit enter, and both of them they get concatenated. So that's the way in which we can understand about strings. So it's quite possible for us to do very powerful set of operations on strings. Just have a look at a couple of examples here. It's possible for me to repeat a pattern of string. For example, if I have string A, well, wait a minute, is that a string? The answer is yes. Please don't think that when I put a single quote here, it is a character. No, it is still a string. On C language or C++, we say that if something is written inside single quotes, it is it is a character. So it indicates the ASCII value of a character. But if I put something in double quotes, we call that a string in C, C++. But here, you can either make use of single quote or double quotes for the purpose of indicating strings. So if I have A, and if I can simply say star 4, this statement is going to duplicate string A 4 times, as simple as this. There is no any necessity of having a for loop or some kind of looping structure for the purpose of repeated display of this string. And if you have a different pattern altogether, the same thing gets duplicated a number of times. So you can create an empty string or using single quotes or double quotes as shown here. This is one more example where a different pattern is being shown here. So A star 4 plus B times 3, if I say like this, the pattern gets repeated those number of times. Now it's also possible for us to index and slice strings. Now, if you just look at the string here, for example, A, um, the string is night, K and IGHT. So A of 0 would indicate K, and A of 3 would indicate G. Now, what about A of -1? Well, let us try to understand this with the help of a very quick example and then go further. Now, let me just have a string like A is equal to night, and let me just check the value of A. Okay, it's night now. So if I say A of 0, that gets me K as expected. And if I say something like A of -1, well, I'm getting T as output. I'm getting T as output. So you can see here that negative indices are not error in Python language. Negative index just means that I start counting from the right hand side of the string. So A of -1 is going to get me T as output. Now let me see what will I get if I write A of -2. Understandably, G. It just goes on. So this is how we can index into different parts of string. It's also possible for us to have slicing of strings. The meaning of slicing is you just try to take different parts of string and then copy it for the purpose of any other operation. Now let me see what happens if I have something like A of 1:3. Now just for your reference, I'm trying to type in A. So the string is night, K-N-I-G-H-T. If I say A of 1:3, now this indicates the starting index of the character I want to consider, and this indicates the limit. So I'm going to have the characters extracted from 1 to 2, not 3. So that means this value is excluded when I extract the characters. Let me see what happens if I do something like A of 0, sorry, A of 0 colon, let's say 5. I can observe here, index 0 implies the character K, and then I just go on all the way up till 4. So 5 is excluded. That's very important. And all other sorts of possibilities do exist. Now, if I say something like this, there is no starting index value, there is no ending index. So obviously, I'm going to get the complete string night, as simple as this. It's also possible for you to actually have some starting value and then ending value, and then let's say I start with 0 index and I want to go all the way up till index, let's say 6. That means I consider the entire string. Now let me just see what happens if I write 2 here. Now you can understand that this is the starting index value and this is the ending index value. This indicates the step size, or it's called stride. I'm just going to type it here just for your understanding. It's called a stride or step size. So this stride is going to tell me how many number of characters I need to skip for the purpose of extracting the characters in a string. So starting from 0 till 5, I go ahead, and then every second character I'm going to extract, and hence the output is K, I, and H. Well, if I do something like this, for example, A of colon, there is no starting index, there is no end index, and then let's say the index for stride is 2, I still get the same answer. So absence of starting index and ending index means that I should consider the entire string. Well, let's try to see what kind of output we get if we have something like A colon colon minus 1. We hit enter and look at this. We got the string in the reversed format. Now, reversing a string hasn't been so easier, right? When compared to doing it in C or C++ or any other language. You just have the stride index as -1 for the entire string, and the string gets reversed. So it's quite possible for you to perform all these operations with the least amount of effort in the case of Python language. So indexing implies I try to look at a character at a time. Slicing implies I try to perform extraction of a different set of characters at a time. Now, these are the different common string methods we have. When I say a string method, the string related functions we have. So upper, basically it is meant for returning a copy of the string with all characters in the uppercase. Then similarly, we have also lower, replace, join, is alpha is going to be used. It returns true value if all the characters in the given string are alphabets, and it doesn't consist of any special characters or digits. Is is one more important string method which gets me true as the answer if the contents of the string are all digits and not alphabets or any special characters. One simple example I have shown here. A is equal to Java, Python, C+, and Fortran. I'm going to say a.isAlpha. So isAlpha will check if A consists of all the alphabets. Well, the answer is false. It returns false value because there are two plus symbols here. So these two plus symbols simply defy the fact that A is consisting of completely alphabets, isn't it? Now, let's look at B is equal to A dot title. So this title method is going to convert string A into title case string. So that means the first character gets converted into the capital letter, as simple as this. In fact, this is just a very small set of string related methods I have shown you. Now, please mark this slide because this is very, very important. It talks about Python objects. Well, anything and everything in Python is an object. We can call it that way. But the cornerstones or the pillars of Python language itself, there are four: lists, tuples, dictionaries, and sets. Now, lists are indicated with the help of square brackets. Tuples are indicated with the help of parentheses. Dictionaries with the help of notation like this, the flower brackets, and the sets are indicated with the help of this kind of representation. So it is these four data structures which actually help us in implementing the solution to the most complicated example or problem in the most simplest possible way possible. So let us consider a different set of Python objects. First of all, let us talk of lists. List is an ordered mutable array of objects. I repeat once again, it's an ordered mutable array of objects. We understand the meaning of array of objects. That means there is a collection of some data together. But the meaning of ordered means at the 0th location, there is some data. At first location, there is some other data. At second location, there is some other data, and it just goes on. The word mutable implies that you can change the contents of this particular list or object. Well, let us try to very quickly go through a quick demonstration of how we can work with the lists. So L is equal to, I indicate a square bracket. and then I'm going to say 1 comma 2 comma, let's say 3.4, and then we have let's say, look at this. Now this is very significant. It means that list is basically an array of objects, correct? But of what type? The first object is an integer, the second object is also an integer, third one is a float value, fourth one is a boolean value. I can have true or false, right? So in this case, I'm having a boolean value true, and the fifth one is a string. It just goes on. So even if I say L or list is an array of objects, by default, please don't think that array should have similar type of data together. No, it can have dissimilar or heterogeneous type of data bundled together. Now, this is ordered because L of 0 corresponds to a certain value, and L of 4 also corresponds to a certain value, and they don't change their places. So the content of list of 4 is a string hello, and hence it is getting displayed here. Well, all the operations that I've shown you on strings are equally applicable here. For example, you can index into a list, index into any part of the list, or slice it, so on and so forth. Let's try to understand how we can actually slice different parts of string. For example, L 0 colon 3. If I do like this and hit enter, the original list consisting of all these data members now is truncated, and we just have 1, 2, and 3.4. That's it. So index 0 has value 1, index 1 has 2, and index 2 has value 3.4. Very simple and straightforward. Now, out of curiosity, let me see what happens if I do something like L of 4 followed by 0. I hit enter, and I get the output as H. So just for your reference, I'm trying to show you the contents of list. So L of 4 implies the value stored at index 4. That is supposed to be hello. But with the help of second indexing, I'm just trying to refer to just 0th position in that particular 4th index at itself. So that gets me the letter capital H. So this is how easily we can access different parts of a list. It's also possible for you to perform any other set of operations like sorting a list, or finding the max in a list, or minimum value in a list, so on and so forth. Let's go further and then understand a few more important aspects. So the same things I have displayed in this particular slide here. So there are different things indicated. In fact, a list can also consist of a list itself. In this case, list 2 has contents like 2, 4, minus 0.1, and then there is a list, right? And then there is a value true. So a list can contain another list as one of its contents. So the same thing, I'm just trying to put it on the slide, indexing and slicing of a list. So you can index at any given location. You can also try to slice it from some starting value to end value, so on and so forth. This is a partial list of some of the list methods we have. Append is going to add a new incoming element to the existing list. Similarly, we have extend, which is going to extend the list with the elements from another list. Index is going to return the lowest index of the list containing a particular element, so on and so forth. So you can perform insert operation, pop operation, or reversing list in place operation, sorting, copying operation, count the number of elements, so on and so forth. Once again, I just want to tell you that this is simply a partial list. So a couple of other examples I have shown here. This is how you create a null list, and then you keep on appending different values. For example, if the incoming data is 4, then you would say q dot append of 4. And if you look at the value of q, the output will be 4. And then if you say q dot extend 678, please note 678 is a new list, right? So this is going to be added up along with the existing list, and hence the output will be 4678. Insert operation is shown here, where I'm trying to insert a new value at a given specified index. Remove operation along with index operation also. So index is going to tell us where the actual location of a particular value that I mentioned is inside of a list. Sorting and reversing, they are also quite easy, simple and straightforward, but we just have to be slightly careful with respect to a couple of variations of how do you sort a list or how do you reverse a list. The second important pillar is called the tuple object. The tuple object. In one sentence, I can just tell you about this. It is as similar as or as same as the list object. There's only one thing, and that thing is that a representation obviously has a different notion here. I make use of round brackets or parentheses. There is only one difference, and that is a tuple is not mutable. I repeat, tuple is not mutable. What does that mean now? I just go back to the spider IDE. So this is what we have seen. L as a list which consisted of different types of data. Now, what happens if I do something like L of 0 is equal to 11? Okay, L is equal to. Now look at this. Initial content of 1, 2, 3.4, so on and so forth is now changed to 11 to 3.4, and it just continues. That means I'm able to modify the contents of list at any given index. I repeat, I'm able to modify the contents of list. Well, this is called mutable property. Tuples are not mutable. I'll just give an example. T is equal to, look at the format or syntax, 11, 22, and 33. Now, this is how I indicate it. So if I look at the contents of T, it says 11, 22, and 33. Now, let me just try to index into a particular location, T of 0, it says 11. Now, I just want to modify it. So T of 0 is going to be equal to, let's say, 99. Well, there is an error. There is an error because the contents of tuple cannot be changed. So this is a very, very big difference between both of them, lists and tuples. Okay, let's move on. The best use of tuple is in terms of tuple packing and tuple unpacking. I'm just going to tell you what this means. Tuple packing is a concept where if I just try to say something like T is equal to 1, 2, and 3 without any syntax at all, this gets converted into a tuple. Tuple unpacking is one more concept where I can do assignments like this: A, B, C is equal to 97, 98, 99. So this will be equal to A being equal to 97, B equal to 98, and C is equal to 99. So this is a very, very shorthand way of assigning the values. So this concept is called tuple unpacking. Well, in Python, you can do like this: A is equal to 97, semicolon, B is equal to 98, and C is equal to 99. But this is not a very, very preferred way of doing it. When tuple unpacking is available, why should you go for it? So the use of a tuple can be seen in a very simple example, the swapping of two variables. All of us are very well aware of this logic. So we create a temporary variable called t. First of all, we assign the value of a to t, and then we assign the value of b to a, and then t to b. So this is the actual logic for swapping two variables. But using tuples, this kind of headache is non-existent. I simply say a comma b is equal to b comma a. As simple as this. A comma b is equal to b comma a. That means b gets assigned to a and a gets assigned to b. This is the example of tuple unpacking, isn't it? So that's how we find the examples of usage of tuples. The third important cornerstone is called a dictionary. So dictionary is basically an associative array, and it contains any type of values, objects. What does that mean now? It means just like in the real life dictionary, if I look at a word has a particular meaning, right? A word has a particular meaning. So the word I'm trying to search the meaning for is called a key. And the meaning of the word is called the value of that key. So we basically talk of key and value pairs. Now, each item is indexed by a unique key, which may be an immutable object. That's a very important thing. Straight away, let's look at an example. Now, this is how a dictionary looks like in Python. So here, the name of dictionary is called height. I'm trying to make a list of very tall buildings across the world and their heights. So let's say Burj Khalifa, this is a string actually. This is a key and its value is 828 point units. 828 point or 828.0 units. Then we have One World Trade Center colon 541.3 units, Mercury City Tower. It just goes on. It just goes on. So it's very important for you to have unique key, but the value of this number can be different. It may not be unique or it cannot be any number. Okay. So basically, this is how it's going to look like. You can always change the contents of it if you want to do so. How do I retrieve the contents of such a dictionary? I'm just going to say height of One World Trade Center in single quotes. So that directly gets me the output as 541.3 units. Then it's also possible for you to assign this string to a variable. It's a string variable now, and say height of building, height of Carlton Center in this case. So that will be 223.0 units. Look at this. Height of Empire State Building is equal to 381. If I say like this, it means that I'm trying to change the values of the contents of a dictionary. So it means that a dictionary is a mutable data structure. That means you can change the contents. The fourth important cornerstone of Python is a data structure called sets. All of us know about sets. The meaning of membership of an element into a set, non-repeatability, cardinality, if two sets are equal or not, if set A is a subset of set B or vice versa, if set B is a superset of set A or vice versa, what's the meaning of proper subset, so on and so forth. All these concepts still remain the same. The basics remain the same. A couple of examples I've shown here for you to understand. If I have created certain sets, I can perform union operation, intersection operation, disjoint operation, so on and so forth. Now, these are some very important set methods. Once again, the list is not complete, it is just partial. So I can just check if two sets are disjoint or not, or if set A is a subset of set B, or if set A is less than or equal to other set. That means if it's a proper subset or not, so on and so forth. So with this, we conclude the different types of data and data structures available. I'm going to go through very quickly the flow control and then start with the plotting functions. We have for loop available. Now let's look at the syntax. For and in. Now these are the keywords. Now this item is like an a loop index. For example, in C language, we would say for I is equal to 0 to I less than n I plus plus. So such kind of loop index is indicated as item in this case. So this is going to be defined by the user. And then we have iterable object. That means something to go through, iterate through is going to be mentioned here. This is going to be followed by a colon at the end. One simple example, fruit underscore list is equal to apple, melon, banana, orange, so on and so forth. So please note here, the fruit list is basically a list of strings. It's a list of strings. Now, a very simple for loop is going to be used like this. For fruit in fruit underscore list. Now, please don't confuse this fruit with this fruit underscore list variable. Now, fruit underscore list is the actual list where the different types of fruit names are stored. So when I say fruit here, it is just a loop index variable. So this value is going to range from 0 to max number. So I just simply say print followed by fruit. So we will have individual outputs like apple, melon, banana, and orange, so on and so forth. By default, we make use of 4 spaces to indent. For example, you can see here dot is given here. 3 places are left, and then on the fourth line, fourth space, we start indicating it. Now, if you don't follow this convention in Python, then the program won't run. So indentation is very, very important. You can just go on having any number of nested for loops as well. One more simple example is with a small modification. The fruit list is same, and then I have double for loop. So for fruit in fruit list, for letter in fruit, what does this mean? Now just look at the inner for loop. Inner for loop consists of loop index letter. Now this should vary in fruit. What is fruit? Fruit is the loop index variable in the outer for loop. So if I look at the value of the first index as 0, then the content is apple. Now this content will be manipulated in the second for loop, and it says print letter. What is the meaning of letter? Letter implies each and every character of this string followed by a dot at the end. So I'm going to have the output like a dot p dot p dot. It just goes on. So all these contents are going to be displayed like this. There is also a very handy range type available in Python. So if I say something like range of 5, I will get the values starting from 0 to 4. Once again, this number is excluded. You can also dictate the starting value of range. You can say range 1, 6. So it will be having 1, 2, 3, 4 up till 5, excluding 6. In fact, you can also have strides, the step size, when you say range of 0, 6, and 2. So the starting value is 0, ending value must be 6, in fact 5 in steps of 2. So the output will be 0, 2, and 4, because after 4, if I increase the step size, it reaches 6, and 6 is not allowed, right? Similarly, you can also have a negative stride value or negative step value, and hence the output will be as shown here. While loop. This is once again as simple as what we have seen in any other programming language. So while some condition is true, I'm going to execute the body of it. Now, there is one important thing you must understand, and that is regarding where this while loop gets over. So there is no any opening parenthesis or closing parenthesis or flower brackets here. By default, whenever you have one extra space indented here, one extra line here indented here, then it means that the body of while ends. So in this case, I'm just trying to print the contents from 1 to 10 using a simple while loop as shown here. The control flow structures correspond to if-else statements and if-elif-else statements. There is no switch case statement available in Python. Let's start with some important plotting functions with pylab. Please note, pylab is basically a package. What does that mean now? Please understand, matplotlib is a very huge library of different packages bundled together. Matplotlib. Pylab package is similar to MATLAB, but in Python. It is similar to MATLAB operations in Python, and hence the name pylab. Py stands for Python, and lab is taken from the later part of MATLAB, so pylab. So this pylab package basically gives us a very rich set of methods or functions for the purpose of data visualization or data interpretation. So first of all, we must be able to import the pylab package into our program. For the purpose of basic plotting functions, we have something like this. Okay, ax is equal to 0 to some numbers. So it's very easy for you to understand that this is a list, isn't it? Similarly, I have the second list ay with some data here. I simply say pylab.plot ax comma ay. So x gets plotted against y, and hence I simply say pylab.show. As simple as this. So let us quickly go through a very simple exercise or example based on this concept. I'm just going to go over to the Spider IDE, and then let's try to open a new file. And what I'm going to do is I'm going to have something like this. Okay. Let's say ax is equal to, shall I say range? Because I know that range is something like, giving rise to a set of values now. So I'm going to have range of, let's say 6, and then ay is equal to, or just for clarity, just for the explicitness, I'm going to have different values of this being indicated like this. 1 through 7, and then corresponding numbers I need to have as a output, right? So I'm going to have 0.1, and then 0.2, and then 0.3. Just for the sake of simplicity, I'm going to have it 0.5 followed by zero point 0.6, and then zero point 0.7. Then I need to plot it. So I should say, how do I plot it? I need the package. So first of all, I must import it. So I'm going to say import pylab, and then after this is done, I must say pylab dot plot ax and ay. Once it is plotted, then I need to see it or visualize it. So I'm going to say pylab dot show. Very simple and straightforward. Let's try to run this and then see how we get the output. Okay. Now this is done, and yes. Now this is done, and the way in which we look at the plots is in this particular window, and this is how the window looks like. Very simple. Okay. Now in the absence of this particular statement, you are going to get an error message because the interpreter doesn't know the meaning of pylab.plot or pylab.show. So that is why it's very important for you to have this. Okay. Now every single time writing pylab dot some method or pylab dot some other method is very tedious. So it's also possible for you to truncate it or kind of shorten name like pi, for example. See, please note here, pi is something that I'm going to give it as a short form or shortcut name for pylab. So then very easily I can just try to say simply pi dot plot, pi dot show, so on and so forth. If I once again run this program, I'm going to get the output. Similar output, the same output is being displayed once again. So such is the flexibility offered in terms of the pylab package. Now let's try to go further and understand a couple of other types of plots. These plots are of great help to you when you try to analyze scientific data for the purpose of data visualization. Now, let's try to look at scatter plots. Scatter plots are the plots where you don't want to connect the dots. You don't want to have a linear model being fitted or quadratic model being fitted in the data points. You just have to plot them and that's it. You just have to analyze this trend. So I have given a simple example here, import random. Now, random is one more package available here. This corresponds to a random number generation method. So AX and AY are initiated as two null lists or two empty lists. It's very easy for you to understand that this is an example of a tuple unpacking. Look at this. It's an example of tuple unpacking because we said something like if you write AX comma AY is equal to empty brackets comma empty brackets. So this value is going to be assigned to AX and the second empty brackets value is going to be assigned to AY. So this tuple unpacking concept is being used to initialize empty lists. That's fantastic. Then I have set up a simple for loop in some range and we say AX dot append. We know that append method is basically meant for adding new numbers at the end of a list. That's what we have seen. And then we say random dot random. Now the first random corresponds to the package name and second random corresponds to the actual function name or the actual method which corresponds to generation of random numbers. So when I generate a random number, I place it in AX. Similarly, I place one more random number in AY. I just do it 100 times so that 100 random numbers are available to me in AX and 100 random numbers are available in AY as well. And then I say pylab.scatter AX, AY and say pylab.show. So when I do like this, depending on the random numbers, this kind of plot will be generated. Now, it's also possible for you to say pylab.savefig followed by file name. So you can just save it in either the PNG format or PDF format or APF format, the format of your choice. This is an example of plotting the function y is equal to sine square x in this particular range. Now let's try to plot it for 1000 points. So whenever I have pi, I require the math module. So I'm going to say import math And then for the purpose of data visualization, we say import pylab. And then I'm going to set up the range consisting of xmin and xmax values as ranging from minus 2 pi to plus 2 pi. How do I write pi? I write as math dot pi. So minus 2 times pi to plus 2 times pi. So we look at 1000 data points, and then we create X and Y lists by multiplying them with the value of n. N is 1000. So this is going to create 1000 such values for us. Then a certain set of formulae are given on the right hand side of your screen. So the value of delta x is equal to x max minus x min by n minus 1. Now these are going to be transferred into the Python syntax, and then we set up a for loop for the purpose of evaluating y at each and every value of x, and at the end we plot the graph and we show it. As simple as this. In addition to this, a rich set of labels, legends, and customization is possible. One very important thing is regarding legends. So after plotting the graph, you can try to have a legend corresponding to different parts of your graph in different locations. For example, if the string is best, it is going to be indicated as integer 0. This corresponds to the legend location specifiers. And then if it is upper right corner, then it's going to correspond to integer 1, and so on and so forth. It's also possible for you to fix some access titles. For example, you can say pylab.x label followed by whatever you want to indicate here as voltage. Font size is equal to 16 dot. Well, this is also quite customizable. And then pylab.y label. Let's say you're trying to plot the value of current against voltage, and then with the value of font size equal to 16. So all these things are very much possible. Customizing the plots, different markers are possible with the different colors, just like what we usually do in MATLAB. So if I make use of a dot symbol, the marker used is a dot. If I make use of X symbol, the marker used is a cross. If I use V, then the marker is a downward triangle. Now, P code stands for blue color and G for green, and so on and so forth. So using a combination of legends, markers, and colors, we can have very nice plots being performed here. A couple of examples are given here. If I say Ax is equal to pylab.linspace, this is going to create me a linearly spaced points. Now I calculate the value of AYI and AYE. Now when I say pylab.plot Ax, AYE, color equal to R. Now look at this. When I say color is equal to R, it's going to plot the values in red color. Line style is equal to colon. What's the meaning of line style? Line style corresponds to different ways in which we can plot the graphs. For example, if the code is hyphen, I'm going to make use of a solid line for connecting the dots or connecting the values. Now, if there are minus or hyphen code, it corresponds to a dashed line. If there is a colon symbol, it corresponds to a dotted line, so on and so forth. So when I say line style is equal to colon, using dotted lines, I'll be able to plot the graphs. If I have hyphen and dot, it corresponds to a dashed line. So this particular statement says that I should plot Ax and Ay with red color and line style being dotted and line width being 4. Now, once again, this is very significant because if you want to have a thicker line, it's possible for you to have it. If you want to have thinner line, try to reduce the value of line width. Some other examples, pylab.plot x, y, c equal to g. Now look at the kind of optimization we have. Initially we said color is equal to. Now we simply say c is equal to. This still stands for color. So this statement corresponds to a thick green dashed line. Dashed because I have hyphen code being mentioned here. Well, once again, further optimization is possible when you say r colon cap. So this corresponds to red colored dotted line with triangular markers. So either you can write like this or be explicit and then say color is equal to G, line style is equal to hyphen, so on and so forth. Plot limits can also be fixed using the methods xlim and ylim, xlimit and ylimit. Well, what it means is like you can actually calculate the values from 1 to n, but if you don't want to plot all those values, then it is quite possible for you to fix the x limits and y limits and plot it. This is the syntax. Histograms can also be plotted because they're also an integral part of data visualization. So it basically corresponds to a set of vertical bars like bins, they're called bins, which correspond to the frequency of some data occurrence in a particular interval. Now, this is how we do it. So we simply say pylab.hist. Now, hist is the method for plotting of histogram. Now, the data and number of bins and normed equal to true. These are different parameters which you can see, which you can set for the purpose of getting the desired data representation. Multiple axis plotting is also possible. Now, this is very significant, as I would say. In this case, I'm trying to actually have two different variables being compared together. The reference axis is the same. It's the year 2000, 2001, 2002, and it continues. On the vertical y-axis, I have the rate of divorce or divorces per 1,000 people. And on the right-hand side, we also have, the pound of margarine. I would say margarine is a type of cheese that people consume in the United States, and this is a place in the US. So, in this particular data interpretation, I'm trying to correlate if the rate of divorce is connected to the amount of margarine that people consume. Surprisingly, the data shows that there is some kind of correlation. They follow the same trend, and such multiple axis plotting is also possible using pylab. Let's look at NumPy. NumPy is basically the de facto standard package for all scientific computing in Python. So when I use NumPy whenever I have a number crunching applications. Basically, when I'm dealing with multi-dimensional data, the core data object is ND array. Now, please note, ND array is actually a keyword. It's a method basically, with the help of which I'll be able to create a n-dimensional array of data. What data? It can be int or float or any other type you can think of. Now, why should one go for NumPy? Two important reasons. First one is it is implemented as a pre-compiled C code. Now, that's very good. So from that perspective, the speed of NumPy is very good. Second thing is it supports vectorization. That means you can perform a single operation on an entire array in a single go, and this contributes to the popularity of NumPy. I have just tried to show you a couple of important array operations here. So for the purpose of creating an array, what you would do is you would say a dot np. What is np? Np is some kind of short form that I give to the NumPy package. Observe the first line, import NumPy as np, and then I have indicated the data like 100 and 203. So this is indicated as an array, and then I can just perform any other type of operations I had done in the previous case, as in the previous case. You can always index into this particular array. You can always create an array of 3 rows and 2 columns corresponding to all zeros or all ones, so on and so forth. Transposing of an array has never been easy. So you can just say a dot transpose, that's it. Or simply say a dot capital T, a dot capital T. So the initial content of a matrix or a array, I would say, is going to be converted like the one shown here. It's also possible for you to merge the arrays and split them, or find the adjoint and inverse of a 2D array and so on and so forth. Max and minimum values can also be computed in a given array with the help of max and min as the methods available here. There are also methods available for finding global minimum, global maximum, row-wise minimum, and column-wise minimum or column-wise maximum. You just have to set the parameters appropriately. This is the ND array attributes we have. So we can say np.all of a. This is going to tell me whether all the array elements of a given array evaluate to true or false. np.any is going to tell me if any one of the elements is true or not, so on and so forth. So these are also very important points. Statistical methods are also supported in a big way in Python using NumPy. So as I told you, maxima and minima values can be found out on a given array, like min of A and then max of A, so on and so forth. Different operations are possible in terms of finding the mean. So if the array consists of numbers 1, 4, 9, and 16, mean of x, in fact, np dot mean of x is going to get me the answer. Np dot median will get me the value of median directly. It's also possible for you to find the value of average of all these numbers uh, in a weighted fashion. In a weighted fashion, that means if you say x comma weights of zero point 0.0, 3.0, 1.0, and 0.0, it just means that you have 4 times 3 into 9 times 1 being done, and hence you get the value of output, the value of average. Standard deviation, covariance related methods, correlation related methods are also possible. Another important aspect is with respect to the polynomial evaluation. So this is pretty amazing because we all know about the way in which polynomials can be of quite a use, handy nature in terms of finding the output of any complicated system of equations. So for this, we need to import uh, the package polynomial. So NumPy, so from NumPy dot polynomial, we import capital T P polynomial. So once this is there in our system, we will be able to go further and then use it. A simple example is given here. If I have a polynomial p of x as 6 minus 5x plus x square, please note this polynomial method takes the coefficients always in the increasing order of x. That's very crucial, increasing order of x. So I can just simply say print p or p dot coefficients or p of 4. If I say p of 4, the value of x gets substituted as 4, and I'll be able to get the answer directly. Polynomial algebra is also possible. That means I can kind of add both polynomials, subtract them, multiply, and divide them, so on and so forth. Couple of examples are mentioned here. So the first polynomial is 6 minus 5x plus x square, and then we have 2 minus 3x. So when I say print p comma q, p plus q, I would get the answer as 8 minus 8 and 1. The corresponding coefficients, they get added up. Similarly, when I say print p minus q, subtraction of corresponding values of coefficients will be done. Then print p star q and p slash slash q and so on and so forth. It's also possible for you to find the values of roots of a polynomial. Calculus support is also there through NumPy. So it's quite possible for you to find the derivative of a given expression. So for example, 6 minus 5x plus x square. So if I say print p dot deriv, the first order derivative will be minus 5 and 2. That is minus 5 plus 2, as you can see here. Now, if I want to go with the second order derivative, I just have to say p dot deriv of 2. So obviously in this case, just 2 remains here. So this is as simple as this. Integration is also done. For example, the upper corner of your screen indicates some example where we have integral 2 minus 3x with respect to x. So the actual answer is indicated here. The lower bound is L, the upper bound is x. At the end of it, we also need to have a constant of integration k. So usually by default, L is equal to 0, k is equal to 0, but it's also possible for you to mention these values according to your requirement and then get the answer. So we would say print q dot intig, that's it. And if you want to change the value of lower bound, that is capital L, you would say q dot intig L b and d is equal to 1. The value of L is equal to being 1 here. And if the constant of integration has to be 2 in your case, then you would say q dot intig k is equal to 2. It just goes on. A linear set of equations can also be solved using the features provided here. So if I have a linear system of equations, it can always be converted into a matrix notation like this. This is very well known to us. Then what we must do is we should solve for the values of the matrix X. So that will be equal to inverse of this matrix times the RHS. How do I do it? So let's consider an example. If the system of equations is as shown here, I'm going to first of all create np.array with all the coefficients corresponding to the first matrix, then np.array corresponding to the coefficients on the RHS or the constant values 8, minus 20, and 7. And then I'm going to say np.linalg, standing for linear algebra, dot solve. When I say this, the values of x1, x2, x3, for example, in this case, will be solved, and we get the answer as shown here. So matrices are also provided in as a part of NumPy. Matrix is always a two-dimensional array. In fact, the higher level dimensions are also quite possible here. So NumPy matrix class is a subclass of regular ND array. That means when I look at ND array object, it can get me an array of n dimensions. But when I look at the matrix as an array, it's an array of size two dimensions. That's very crucial. How do I create a matrix? For the purpose of creating a matrix, we have the method called matrix itself. So I sincerely hope that you understand the difference between ND array and matrix objects, matrix methods, sorry. So if I try to print the value of a matrix that I have created, it's going to be printed like the one shown here. Different matrix operations are possible. I can multiply two matrices. So obviously, I need to have compatibility in terms of the number of elements. I can also try to raise the power of a matrix to a scalar value as shown on the RHS, and we get the answer as shown here. Then one more example is shown here in terms of matrix multiplication and exponentiation. One more example as applied to the electronics engineering or electrical engineering is shown. Given a circuit with different resistors and voltage sources, the KVL, Kirchhoff's voltage law, can be used for the purpose of deriving a set of equations, and from them I want to solve for the values of current I1, I2, and I3. Now this is not something new. The same concept was dealt in the form of solving a set of linear equations in the previous slide, a couple of slides ago. Its real-life application is as shown in this slide. Then the last part of today's discussion, we're going to talk about SciPy. SciPy stands for Scientific Python. It's basically a library of Python modules for scientific computing. It's absolutely free. You can always download it from any of the websites. Sourceforge.net is one that I have gone through for the purpose of downloading it. Now, it provides for different set of optimization related functions and integration, interpolation for image processing, manipulation, so on and so forth. Slightly new syntax we need to learn, and then we'll be able to comfortably use SciPy methods. The SciPy method, methods are also included as a pre-compiled C code, and hence this tends to be very fast. Different physical constants and special functions are also provided. For example, array functions, elliptical functions, Bessel function, spherical Bessel functions, and so on and so forth. The values of different physical constants can also be indicated. For example, I can simply say import SciPy dot constants, SciPy dot constants as PC. So from this point onwards, I can just say PC dot physical underscore constants followed by whatever constant I want to understand. For example, Avogadro's number or Avogadro's constant. Then the output will be its number or its value. Then it's also possible for you to say what is the value of a particular physical quantity. For example, PC dot value followed by elementary charge. So it says 1.6 into 10 to minus 19. Obviously, its unit is coulombs. We know this. So for the purpose of finding unit, you should say PC dot unit followed by elementary charge. It returns capital C. It stands for coulombs. And then for the purpose of indicating the precision of whatever value you want to read, you can make use of PC dot precision followed by the argument here. Then it's also possible for you to have a look at different constant values like small c, capital R, and small k, standing for speed of light, gas constant, Boltzmann constant, so on and so forth. This is once again a partial list of different SciPy constants available and the way in which we can use it. Integration and ordinary differential equations are also supported in a big way. I just want to bring it to your attention that integration is something that we already saw in the context of NumPy, but it's also possible in this case of SciPy package. The only thing is we just have to look at the syntax. Okay, so definite integrals can be evaluated corresponding to a single variable. A simple example is shown here. So you just have to say a quad of f comma 1 comma 4. Quad is going to get me the integration of this particular function under consideration. Now this function f is indicated as a lambda function. Okay, then double integration or higher order integrations are also possible. Only thing is you just have to be familiar with what kind of function or method is supported. We have DBL quad or double quad, which stands for double integration. Then some kind of short form or shortcut notation is available for indicating the function, the values, and any other parameters associated with them in a single line, on a single line in Python shell. ODE is also supported. Order differential equations are also supported, and then it can be first order or any higher order equations. You will be able to evaluate them pretty easily. Interpolation is also supported. Only thing is you just have to make use of scipy.interpolate.inter p1d. That means different types of interpolation techniques can be had. For example, if given a set of data points over here, then I can just try to just join the dots blatantly directly, or I can just try to have a linear interpolation scheme being used here, or a cubic interpolation scheme being used here. So all of them can be had in terms of plotting the functions. For example, pylab.plot x2 comma f underscore linear of x2 and label being equal to linear and cubic, so on and so forth. All the other manipulations in terms of x limit, y limit, legend, all of them are quite possible here as well. Now, as the last part of today's discussion, let's try to look at some add-on inputs. This is regarding image processing. Well, in fact, image processing using Python itself can be a very huge topic, but I'm just trying to have a very quick review of what one can do using Python for image processing. There is a separate image processing library in Python for the purpose of image manipulation. It's called Python's Image Processing Library, PIL. In fact, the technical documentation also refers to this as Pillow, P-I-L-L-O-W. You either call it pill or pillow, both in the same. So what we do is we say from pill import image, and then we can do all these operations, pixel-based manipulations or filtering or image enhancement or geometric manipulations, adding images or adding text to images, creating thumbnails, so on and so forth. Now, there is one important thing I just want to make a mention of. Python's image processing library, PIL, gives a set of functions, no doubt. But the rate at which it is growing seems to be somewhat very slow. In fact, according to what I have gathered, it is said that the latest update to PIL library happened way back in 2009-10. But all these things still work fine, no problem. But for the purpose of having more ease, then maybe you just want to explore different libraries. One such library I can just make a mention of, which is an open source library. It's called OpenCV library for the purpose of image processing. So OpenCV can be combined with Python for image manipulations. So I just have tried to give a brief glimpse of how the functions can be used. For example, image.open followed by the file name is going to open the image, and then I can just read the image, show it, save it in a different format. I can find the image size by using im.size. Now this is going to be an attribute or feature of image, and im.format gets me what kind of format this image is stored as, so on and so forth. It's also possible for you to convert to grayscale images using the appropriate method called convert. You can just show them, so on and so forth. A very small set of various functions I have just shown here, like in terms of open, in terms of image chops dot darker, save, thumbnail, show, so on and so forth. It's quite possible for you to crop them as well and then save it in a different format according to your wish. So I just come to the summary part of it. I know we just overshot in terms of time by more than 10 minutes, but let's try to look at what we have to say. So in this webinar, we have been through the basics of Python programming language in terms of what Python is, what kind of type of data are supported, what type of data structures exist, and how we can use them. Language elements like for loop, while loop, and if statement, and absence of switch case statement. And we also have seen some very powerful libraries and packages like Pylab for image, data visualization, NumPy, SciPy, so on and so forth. Just to wind up, I want to say that Python is quite the thing now, quite the rage for going for artificial intelligence, machine learning, and deep learning. So, a very good basic foundation in terms of the language constructs in Python can actually help us accomplish many more good things. So, with this, we come to the end of this webinar. First of all, I just want to acknowledge the SJR management, the principal Baswaraj sir himself. Thank you so much, sir. And the head of the department, Professor Hemant Kumar sir, the convener, faculty and staff, and not at the last but not least, I would also thank and acknowledge participants for being so patient and listening to me for the last more than 1.5 hours. Thanks are also due to my SDM College Management Education Society, Principal Dr. K. Gopinath sir, Head of the Department Dr. Vijay Madam, and faculty and staff. So with this, I wind up. Now, if there are any questions, we would like to go through them and then answer them. Over to you, sir.
Vinay, give a chance to ask the questions.
Yes, sir.
Or you can raise the questions in the chat box.
Please feel free to ask the questions. Let's try to answer them. Okay, we have a question. What if we want random numbers between a particular range in NumPy? Well, that's possible. That's possible, and the syntax is provided just like what we have in the case of range statement. Range. Now, if you look at the chat box, then I think you'll be able to. Okay. Or I'll just do one thing. I'm just going to share the screen once again now, so that I can just try to write something and you'll be able to see it. Okay. So, like in the case of range, what we had, like 1:10, isn't it? So we had something like this. So similar kind of syntax is also available, where I can have something like random dot random or rand int, where obviously this is the name of package, right? I hope you can see my screen now. So I'll just try to, yeah. So we have the name of package as random, and then the function name can be random or rand int. For example, rand int implies that I want to generate a sequence of integers only in a particular range, for example, 1 to 10. The same thing is true if you just make use of something like random dot random followed by a range, then you'll be able to generate the numbers in the range that you desire. That's very much possible. Hope that answers your question. Yeah. Oh, well, This is a very nice question we have. What's the difference between Jupyter Notebook and Spider? Which one is easier? Well, Jupyter Notebook is something that you need to work on with connection to internet. With connection to internet, there is always the network which is required for working with the Jupyter Notebook. But when you look at the Spider IDE, you can also work in the offline mode, no problem, no problem at all. So, in fact, if you look at the layout of these both softwares, they are quite different. For example, in Spider IDE, I have shown you the presence of text editor, then the IPython console, then the help console or variable observation console. But when you look at Jupyter Notebook, then there are what you call cells. So what you do is you just try to type in one command at a time, and that command gets transmitted to a central server, and then you get the code executed and it comes back to you. So you run your program in the code cell and you give the data in the data cell. There are also different types of cells called markdown cell, which are meant for different documentation purposes, so on and so forth. So um, uh, it's just a matter of personal experience, personal choice, like if you want to go for Jupyter Notebook or Spider IDE. But I prefer using Spider IDE. One can very easily go for Jupyter Notebook as well. Are there different packages for AI, ML, and DL? Well, madam, yes, there are different packages. There are different packages. In fact, any and every kind of operation that you want to perform will have a different package. Just to draw a comparison, I would like to say, if you know about MATLAB, then for the purpose of doing some kind of manipulation with respect to signals, you have signal processing toolbox in MATLAB. Then you have a image processing toolbox in MATLAB. Exactly like that, we also have different kinds of packages meant for AI, ML, and DL. Yes, they are present. Okay, there's one more question. Can we able to convert program from C to Python? Well, according to what I have gathered, that doesn't seem to be possible. I don't know if that's possible or not. I'm not very sure of it. But according to what I have gathered, it is not possible, at least as of now. Um, but if your intention is to have C as a part of Python language, well, it's already there. That means when you look at the earlier versions of Python, it was basically written in C language. So the core part of Python is called C Python, C Python. Okay. Now, looking at the popularity of Python, people have tried to provide some kind of interface so that Python programs can talk to other platforms as well. So it's possible for us to have Python code talking to C program, Python code talking to MATLAB, Python code talking to Simulink software, so on and so forth. Okay, so that's the answer. So do we have any further questions? Okay. Okay, there's one more question. Can PyCharm be used? What do you suggest, PyCharm or Spider? Well, as I told you, it's a matter of personal choice. When in fact, if you use PyCharm, there are different set of possibilities. Like you start writing the code, and then there is auto completion facility, and then there's a different way of highlighting the code, so on and so forth. Well, I would say it's a matter of personal choice. You want to go for either PyCharm or Spider, it's left to you. Okay, there's one more question. Why is it named scientific analysis? Scientific analysis because we did not see or talk anything about how do I make use of Python for web development, right? How do I make use of Python for user interface development, or how do I use Python for system administration? What we saw was regarding the way in which basic data structures like lists, tuples, sets, dictionaries, different loops can be used for the purpose of mainly data visualization like plotting, and doing integration, differentiation, creation of arrays, n-dimensional matrices. How do I operate on them, perform different set of manipulations on them, so on and so forth. So that is why we named saying it's scientific analysis or scientific computing, rather than, let's say, saying something like a web development using Python or image processing using Python. Okay. Can I download the code into a controller? Any separate program? Well, you can download these programs into the controllers. Yes, it is quite possible for you to do that. In fact, if you look at the Raspberry Pi board, it basically supports the Python code itself. So you can uh, write the program, check it, debug it, and then download it onto any of the hardware platforms. Raspberry Pi happens to be one such platform. Okay, sir, how powerful the Python is in embedded systems applications? Well, sir, as I told you, embedded system applications would require us to have a very, very low value of time to market, TTM. So, if you're able to rapidly prototype your application and then release it into the market, then you have an upper edge, or upper hand. So from that perspective, I would say Python is still very, very relevant in doing embedded system applications. And just look at the ease with which you can develop the applications in the shortest possible time. That's the power of Python. Okay. When we are plotting, we are using colors, right? In that example, have used R for red and G for green. Now, these are all default keywords for colors or not? Well, the answer is yes. Madam, yes. R for red, G for green, so on and so forth. These are a default uh, codes used for different colors. Yes, you are right. Any other question we have? Do we have any more questions, sir? Okay.
If there are no questions, we'll go for the next program.
Yes, sir, sure. Sir, thank you so much for the opportunity, sir. Principal, sir, thank you so much. Thank you.
Yes, sir. I will give the vote of thanks. Hello, sir.
Yes, sir.
Okay. Uh, we enjoyed a memorable journey in the green field of Python. 2 times Best Teacher awardee for his exemplary performance in teaching, Dr. Siddalingesh S. Navalgund, Assistant Professor, SDMCET, gave a highly informative and lively talk on scientific analysis using Python. I think he should be awarded one more time the Best Teacher Award in 2020 and 21 also. Today's resource person, he covered and gave a detailed talk on basics of Python, data types and data structures, flow control, file handling, dictionary, plotting with Pylab, equation solving, matrix operations, circuit analysis, NumPy and SciPy. It was delivered very lovely, very lively. I thank Dr. Siddalingesh S. Navalgund for his scholarly talk. I thank EdCraft 360, Dr. Vinay and Dr. Girish for giving a technical support for this webinar. I also thank the SGRES management, computer HOD, Professor Hemant Kumar and his colleagues for organizing such a wonderful webinar. I thank all the participants for making this webinar a grand success. Thank you one and all. Vinay sir.
Hello, thanks for attending the Python session. It was really nice. Thanks, Navalgund sir, for your wonderful presentation, and it was very interactive too. I just have a small announcement that every day we'll be sending 100 certificates to the participant who have attended this training program. Along with that, the one important information is I've started a startup called Aircraft 360, where we'll be giving training on different technical and technological tools, which they can be incorporated real time in the classroom and make the classroom very interactive and digitized. So we'll be conducting different programs related to this, like faculty development program and the technological tools for students and teachers, all those things. And these are the training. So if you want G Suite for schools and colleges, and and also we also conduct training related to level 1 educator of Google and the Google certified trainer and certified innovators. Along with that, we have a session on creative design, graphic designs. And we also conduct master classes, technological boot camps, and how to develop the website within 1 or 2 hours, and what is the importance of digital marketing and what are the tools. And we will be training on all those things. Along with that, we also these are the topics which will be covered in our training sessions. So we can take this snapshot of this, and there will be different tools for each and every topic, and we'll be covering all the tools and techniques, and all our sessions will be hands-on, and it will be very interactive. After implementing these tools in your classroom, you can get a significant impact in the way the students respond and the students' participation. So I strongly suggest, if any college or school who is going to look for any digital trainings or certifications for their teachers, please contact Aircraft 360. And separately, we also train the teachers and faculties for Google certified certifications, like Educator Level 1, Level 2, and certified Google certified trainer and innovator. So I've already completed certified trainer, and where you can showcase your badge all around in the signature, and you can be a certified Google trainer, and you can train the people in schools and colleges in different part of the world. So along with that, we also come up with a small book of 25 digital tools which can be used, which you can learn and which can be used practically in your classroom, so that you can see what is the essence you'll be getting from the students, and also the students interactive when you start implementing this kind of tools. And this book consists of 25 tools, and all the pages are color, and we have included a lot of examples where you can go through this along with the screenshots. It is a handy book where you can follow step-by-step process, and you can get the essence of each and every tool. And if anyone wants this book, so please kindly send us the email. This is for 499 rupees. We will be sending it to your home through courier. And this is our Aircraft 360 website, and you can follow us on YouTube. You can send mail to aircraft360@gmail.com, and our website is aircraft360.in. And you can also contact us to this phone number, and follow us on Twitter and LinkedIn. So that's it from my end. Thank you very much for everyone attending this session. So, and I strongly recommend you to kindly subscribe for our YouTube channel, where we'll be releasing short videos in the coming days related to technology and digital, and how it can be implemented in the classrooms. Thank you.